Okay, there we go. So thanks everyone for joining today. What we're going to do here for the next 90 minutes or so is go through the requirements that we need to make sure we're following in order to ship lithium batteries and lithium battery powered products in accordance with the US DOT regulations. So there's all types of different lithium batteries. I know for our operation, we have a lot of smaller lithium batteries, and even for those smaller lithium batteries, there are specific regulations that we need to follow for both international and domestic transport of spare batteries, charging cases, hearing aids, anything powered by a lithium battery. We need to make sure that we're shipping it in compliance with the Department of Transportation regulations. That's the intent of today's training. My name is Mike Pagel. I work for a company called Hazmat Safety Consulting. And what we do is anything and everything related to DOT hazmat regulations. So we do a lot of trainings like the one we're doing today, do on-site compliance assessments, mock DOT audits, help out with special permits, approvals, job aids, etc. So been a private consultant now for about 7 years. Prior to that, I worked for the Pipeline and Hazmat Safety Administration, which is the agency under the DOT umbrella that writes all the rules and regulations for transporting hazmat in the United States, including transporting lithium batteries. So a couple notes here as we go through the training. Here's what we're looking to do today. We're going to start off with some general awareness, which is really where the regulations come from, what are dangerous goods or hazardous materials, and what are some of the enforcement processes that we need to be aware of. From there, we're going to talk a little bit about lithium batteries in terms of how to classify them and what their hazards are. And then the final portion is going to be really just instructions on how we have to package, label, and in some cases, fill out shipping paperwork for shipments of small lithium batteries like the ones that power our products. I will note here that any regulated training course, which is what this is, after today's course, you will be certified to prepare shipments of small lithium batteries. But any regulated course like we're going through, we do need to be trained and tested. So this training presentation will cover the training portion, but there is going to be a link over to a quick quiz, just sort of as a knowledge check to make sure that we're understanding what these rules and regulations are. So after today's presentation, I'll get this training material over to Cheryl along with a link to the quiz where you can go through to complete the quiz and actually get that training record that I will produce. So the best place to start is really just dangerous goods. So I guess I'll note here that you'll see this term dangerous goods. You'll also see the term hazardous materials. They are interchangeable. So in the United States, we tend to call them hazardous materials. The rest of the world will refer to them as dangerous goods. But ultimately, what we're talking about are articles, chemicals, substances, anything that poses a risk to health, safety, property, or the environment when in transport. So there are thousands and thousands of different chemicals, articles that are regulated in transport. So if your products, in this case, our lithium batteries, are subject to hazardous materials regulations, so we need to make sure that we are shipping in accordance with those regulations. Now, again, there are thousands and thousands of different regulated products, but each hazardous material or each chemical substance is going to be categorized into one or more of the 9 hazard classes. So we're going to run through all those 9 hazard classes here, and this will give you a scope of what types of materials are regulated in transport. Let's start at the top. So class 1, these are explosives. So explosives, I think there's actually an official definition, but the definition is article or substance designed to function by explosion. So that should be pretty straightforward. This is going to be everything from, defense weaponry, but the more common things you'll see shipped as explosives would be like fireworks, ammunition, some airbag inflators. I don't think we're shipping anything that would be falling under class 1 explosive. More common though, class 2, these are gases. So these are flammable gases non-flammable compressed gases, and poison gases. So if you think of, a big nitrogen cylinder, that would certainly be considered class 2 compressed gas. Propane tank would be a good example of something regulated as a class 2. And then another more commonly shipped product would be an aerosol. So any type of aerosol is contents under pressure and therefore is regulated either as a flammable or non-flammable gas. So just be aware again that if you are shipping or transporting things like aerosols, that those are also considered regulated hazardous materials that would require some level of specific packaging and labeling. As we move down the chain, class 3, these are flammable liquids. So these are easily ignitable liquid materials, so gasoline, ethanol, pretty much anything with a flash point below 200 Fahrenheit is going to come into contact with flammable liquid regulations. Class 4, this is where we see three different things: flammable solid, spontaneously combustible materials, and then materials that are water reactive, or they're called dangerous when wet. So flammable solids, things like matches, materials that are dangerous when wet are, there's a family of chemicals, lithium being one of them, magnesium, sodium, I think, that when in direct contact with water produce a very nasty reaction. And then the spontaneously combustible materials, also some self-reactive substances. I don't think we're shipping anything that would fall under class 4. Class 5, oxidizers and organic peroxides. So oxidizers are things that will contribute or enhance combustion or accelerate a fire. Organic peroxides are usually some chemicals that are unstable or self-reactive, some pretty high level reactivity. There's a lot of regulations in terms of how we have to transport those. But again, fortunately, I don't think we're dealing with anything in class 5. Class 6, these are materials that are toxic or infectious substances. So materials that are toxic, that's pretty straightforward. Things are just poisonous to humans or animals. Infectious substances is a little bit different. This one is classified as materials known or expected to contain a pathogen. So this would be very common in the medical world, where you might have test kits or blood samples or anything that might contain some type of harmful virus or bacteria. Those are also, of course, regulated in transport. Class 7, radioactive materials. So these are things that emit dangerous levels of radiation. Don't think we're dealing with anything like that in our operation, which is good. Class 8, these are corrosives. So these are strong acids or strong bases that are capable of causing destruction of human skin and or metal. So this would be pretty common in some, manufacturing processes where you might have different acids as part of the process. This is also common if you have things like car batteries. So car batteries are typically classified there as class 8 corrosive because they contain that lead acid material. Then finally, class 9. So class 9 is the miscellaneous category. These are mostly substances or articles that the regulators still deem to be hazardous, but they don't fit under the other 8 categories. So here you'll see things, there's certain hazardous wastes, environmental pollutants, dry ice is another example. But for our purposes, the one that we really are focusing on here today, that's going to be lithium batteries. So all lithium batteries, regardless of energy content, size, configuration, all lithium batteries are considered class 9 hazardous materials for the purposes of transport. Now, based on, number in the package, energy content, things like that, the regulations change. So, if you have smaller batteries, you might not have to jump through as many hoops as you would if you were shipping a car battery size, like a Tesla enormous battery. But at its most basic, all of them, all lithium batteries are considered class 9 dangerous goods. So from a very high level, you can probably see the understanding here that there are tons and tons of different chemicals and articles that are regulated in transport as dangerous goods. Obviously, again, today we're focused on batteries. But the dangerous goods regulations or the hazardous materials regulations, they are global. So what I mean by this is, we're operating here in the United States, so the the regulations that we're following that are applicable here in the US, as you see, is the 49 CFR. The 49 is the Code of Federal Regulations, parts 100 through 180, which are, excuse me, written by the Pipeline and Hazmat Safety Administration. So those are certainly the rules applicable here in the United States, but dangerous goods regulations are applicable throughout the world. So if we're shipping anything by ocean transport, like on an ocean vessel, we would be subject to the requirements of the IMDG code. If we're moving things via highway in Europe, there's the ADR standard. In Canada, there's TDG, Transport of Dangerous Goods Regulations, and then another very common one for us likely is going to be air shipments. So anytime you're shipping something via aircraft, you're going to be subject to the rules of either the ICAO technical instructions or the IATA dangerous goods regulations. Now, this training that we're walking through here today, we're going to be taking the requirements from these regulatory standards and sort of teaching them in a different format. But if you do want to go to the actual source, if you want to see how it's written in the regulations, these are the publications that you would need to reference to actually see where these requirements are coming from. And it's also probably worth pointing out that these standards here, these are baseline safety standards. So these set the minimum conditions on the transport of dangerous goods. So let's just use the air example. If you go into the regulations, it's going to tell you you can ship lithium batteries on an aircraft. You just need to make sure that the package is less than a certain weight, that you have the correct marking, labeling, and shipping paperwork. So the regulations are the minimum standards. But one thing that we run into for both air and ocean transport is that individual carriers, air carriers, for example, can and do impose standards or restrictions above and beyond what's in the actual regulation. So the example would be say the regulations allow me to ship this type of lithium battery on an aircraft. If I'm a private company like UPS, FedEx, Lufthansa, I can impose my own company policies to say that, yeah, even though in the regulations you can ship this type of battery on our aircraft, we as a company are just not comfortable with it. Therefore, we're going to prohibit these types of lithium batteries from being shipped, right? So it's important that as shippers, what we're doing is we understand what the actual regulations are, and then we also go on to that next step to make sure that we're working with our carriers to understand that, yes, not only do the regulations say we can ship X, Y, and Z, but our carriers will accept those shipments as well. So fortunately, at least in our business, we're shipping a lot of smaller batteries. So, batteries that are just lower energy content, therefore typically less hazardous. So I wouldn't expect too many of your carriers to be pushing back. Whereas if you were shipping large lithium batteries, like the type that power a scooter or a drone or something like that, you might get some more pushback. And just on that concept there of the regulations, I did want to mention that many of these standards you actually have to purchase. So for example, IMDG code and the IATA dangerous goods regulations are not available online for free, but the United States regulations in the 49 CFR are certainly available online for free at ecfr.gov. Again, if you wanted to go into the regulations to see where these requirements are written. So one of the things we're here today to do is to provide training. So regulators, DOT enforcement agents put a very, very high priority on employee training. So the way they write the regulations is that they try to capture a pretty wide audience. So what I mean by that is the regulations say that training is required for employees that are involved in the hazmat shipping process. So when they talk about, what is involved in the process actually mean, well, it's things like filling a package, so putting batteries and battery powered products into a package and closing it, putting marks and labels on the package, doing product classification, loading, unloading, transportation, filling out shipping paperwork. Really, for our purposes, if you are involved in the process of packaging, labeling, and transporting lithium battery powered products and lithium batteries, some level of training is required, which is exactly what we're doing here today. So the training in the US is valid for a period of 3 years. So every 3 years, you would then be required to go through what we call just a recurrent training course, just to kind of a refresher training is another way to think about it. But the actual certification is valid for 3 years unless job functions change or possibly the regulations change significantly. And we do want to make sure that all training records, which is what I'm going to produce for each of you after you go through to complete the quiz, we want to make sure that those training records are maintained in an accessible manner on site. So that could be hard copy, that could be electronic version, it doesn't matter. But we do want to make sure that we keep a record of our training because typically training records are the first thing that a DOT inspector would ask for. So if you're getting audited or inspected by PHMSA, FAA, FMCSA, any government agency, usually they like to ask for the training records first because in their mind, understandably, if the company's had no hazmat training, it's probably very likely that there are some other violations in terms of packaging, marking, labeling. Whereas if you can show the agents that you have undergone training and you can produce those training records, oftentimes it gives them sort of an indication that you have a hazmat program in place and that you are operating in compliance. So from an enforcement perspective, as long as we're talking about that, it is important that we keep in mind that it is the shipper's responsibility to comply with the regulations. So what do I mean by that? First of all, who is the shipper? Well, it's not as simple as whoever's on, the from line of the address label. So when the regulations say that it's the shipper's responsibility and therefore the shipper's liability for compliance, what they're really saying is the shipper is the company that performs pre-transportation functions and or the company that tenders or offers the hazmat to the carrier for transport. So for our purposes, anything that's leaving out of our distribution centers, it is going to be Starkey that is going to be the company responsible for those shipments because it's going to be our employees that are performing what we call those pre-transportation functions. So again, that's filling and closing a package, putting the labels on the box, doing classification, loading a truck, things like that. Those are the regulated functions that we're performing. Therefore, it's going to be our company that's responsible/liable for any violations or incidents in transport. So this is, of course, why we want to make sure that we are following all of the necessary requirements as it relates to proper packaging, labeling, and or documentation. And unfortunately, if violations are made in transport, that's where you have the beginning of enforcement action. So DOT enforcement action, it is handled on a case-by-case basis. So there are chunks of the regulations you can go look into where they give you suggested penalty amounts. So for example, you can look into the regulations and it'll say if you put the wrong lithium battery mark on the box, the suggested penalty might be $1,200, right? Those are all suggestions. Really what it is a case-by-case thing where DOT would find some type of violation in transport, and based on the nature of the violation, based on the company's explanation of the violation and corrective actions, oftentimes no enforcement action would be taken, penalties would be dropped. But there are other cases where enforcement results in a financial penalty against the company, against the shipper. And what you'll notice is those financial penalties are typically largest for companies that are frequent violators. So this makes sense. If you're a company that had one violation over the course of 10 years, somebody forgot to put a label on the box or something minor, oftentimes DOT understands that and they'll drop the case. Whereas if you're a company that has, 100 violations over the course of a year, obviously, the DOT feels compelled to send a stronger message with some of these financial penalties against the company. We also see companies that have no training or no hazmat program in place get some pretty stiff financial penalties. Again, this goes back to what I was saying about how DOT regulators really do place a high priority on training. Not only is training required by the law, but if you haven't been trained, it's probably a high likelihood that some of the shipments you're making are not in compliance with the rules. And in the lithium battery world, we've certainly seen some major penalties. So one's from a few years back. Braille Battery was involved in a lot of violations for shipping lithium batteries on aircrafts, and they got hit with a proposed penalty of over $1 million. That got negotiated down significantly, but it still required a major financial penalty, as well as a lot of the company leadership having to exit the firm altogether because they were identified as doing some of these things knowingly, which is obviously a major problem. The other thing, especially in the lithium battery world, this is where you're going to see enforcement agents getting pretty strict and pretty upset, is what we see here. Undeclared shipment or an undeclared package, same thing. So an undeclared shipment is a package that contains dangerous goods, but there are no labels on the outside to indicate hazmat is present. There's no paperwork. There's really nothing to distinguish the hazmat from a non-hazmat package. So in our example, let's say we have some of the hearing aid cases plus the aids. If we put those in a package, let's say we put 10 of those devices in a package, close the package, and there's nothing on the outside of the package to show that lithium batteries are present, that's considered an undeclared package because you're not declaring the hazard in transport. And if those are found in transport, there are significant financial penalties. So you see here on the right-hand side, these are, again, those suggested penalty amounts. So for air transport of an undeclared lithium battery package, you're looking at suggested penalties of $40,000 per package, ground transport $20,000. So this is sort of the number one target for, especially for air transport, is to identify these undeclared packages because they present a major hazard in transport. Not only do package handlers not know that, for example, lithium batteries are in the box, but more importantly, the part of the purpose of the hazmat regulations in general is emergency response. So if there's some type of incident or fire, the emergency responders are going to need to know, for example, that there are 10 packages in the back of the truck that are all containing lithium batteries, because that's going to change how they would react to the emergency. So that's why it's always important that anytime we have hazmat and lithium batteries in a package, that we're communicating that hazard via the appropriate marks and labels. It's also does become a matter of public record. So every year, PHMSA publishes their civil penalty reports where you can go through the database to search companies that got financial penalties against them that year. FAA does a similar thing. So once these cases are settled, they do become a matter of public record. And of course, we want to do our best to stay away from any of these enforcement cases. And this just gets back on our undeclared packages. So I always like to reiterate this point because this is where I see companies like ours getting in the most trouble. And so this is going to be, again, packages without any sort of identifying marks or labels if they contain hazmat. So it's a major safety hazard for emergency responders, large fines I talked about. The other one here, though, is there's a requirement to report this to the DOT. So what I mean by this is if I have a package that contains lithium batteries and I put a lithium battery label on the outside of it, but it's the wrong label, oftentimes, FedEx or UPS, they might see that and either reject the package or put it on hold until it's fixed, but they won't report you to the DOT. On the other side, if I have a package with lithium batteries and there's no lithium battery marks or labels on that box at all, that again is considered an undeclared package. And actually, at this point, per the regulations, the carrier is required to report that package to the DOT. And so there's an incident report form that they would complete that says, what was in the package and who the shipper was. So this is a very, very common way that DOT enforcement agents kind of get their leads on who their next inspection is going to be. So they'll get a report directly from, UPS, DHL, FedEx, whoever, saying that company X shipped a bunch of packages undeclared, and oftentimes, again, that's going to lead to an on-site DOT enforcement visit. So it's always important that when we're shipping our products that we're communicating that hazard correctly. It looks like we have a question here from Cheryl.
Hey, Mike. I was just wondering, so say that you don't have any of your paperwork and there's no labels on the box. How does FedEx or UPS find that? Do they just do random audits on packages?
That's a good question. The answer is not really. So this is another reason that DOT enforcement's all over this, is because they're very hard to find. So if you have a package that's undeclared with lithium batteries in there, it is not standard practice for carriers to really ever open a package. So some of them do perform like the random audit you're mentioning there, but it's very rare because if I'm a carrier and I open a package and I start, scooping around in there, oftentimes the original shipper could get upset. But also, as the carrier, once I close that package, I'm taking on some of that responsibility of the shipper as well. So it's very rare that undeclared packages are found because, number one, the carriers typically don't open these packages. So typically the way that they are found is two things. Would be one, if they break open, if something leaks or breaks open in transport, that's very commonly how these undeclared packages are found. The other way they're found is just on other clues, I guess I would say. So let's say you have a package with the logo of a company that obviously, let's just say Panasonic. Panasonic manufactures millions or billions of lithium batteries every year. So if you are a carrier and you get a package from the battery facility, the Panasonic battery facility, and where it's coming from, but there's no labels on there, that's another way that the carrier might know it's an undeclared package and report you. But in general, to Cheryl's question here, the reality is the vast, 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 vast majority of undeclared packages are never found in transport. But with that said, when they are found in transport, that's where you get into a lot of trouble if you were the shipper of that undeclared package. The other thing I'll mention, just while we're on the topic, oftentimes as shippers, we think of an undeclared package as a mistake, maybe. So you put in a bunch of the hearing aid products, and you forgot to put the label on the box. So that's a mistake, right? DOT doesn't always look at it as a mistake, because unfortunately, there are a lot of shippers out there, especially those that ship by air, that will essentially just hide lithium batteries in the box because they don't want to have to jump through all the labeling hoops. And oftentimes, some carriers will do an upcharge or a hazmat fee for some of these fully declared packages. So in order to avoid the hazmat fee, they'll just hide the batteries in the packages, because at that point, the carrier doesn't know they're in there, and they won't have to pay an extra, $40 per package hazmat fee. So it's, unfortunately, there are bad actors out there, and that's what the DOT is trying their best to combat some of that. And that does bring us to common violations. So I mentioned this already. Year after year, the number one most cited violation of the regulations is training. Training is, again, high priority for DOT enforcement. So if you have not conducted any sort of training, that's typically the first violation that they will uncover. And that is, again, every year seems to be the most common violation cited. But of course, there are others. Undeclared packages, we talked all about that. Failure to use the right packaging, improperly declaring something on a shipping paper, um, marks and labels not applied correctly, or maybe even overlapping or partially covered, or not having the correct emergency response phone number. So there's, again, these are posted every year, civil penalty reports. There's hundreds of them every year, and for various things. But again, I think on the most commonly cited violation, especially in the lithium battery world, it's training and then the issue of undeclared packages. So the last portion here on just the general awareness, any regulated training course needs to have hazmat general awareness, function specific, which we're going to be covering later. And then there's also a requirement that we um, just touch on safety and security awareness. So dangerous goods are dangerous for a reason. So we're talking all about how to properly package and ship them, but just more common sense. If you're working with batteries, which we are, just keep in mind that we understand what the hazards are, that we know emergency response procedures, and that we're handling all batteries and battery powered products carefully, so we're not picking them up and throwing them around the facility. I don't think we're doing that anyway, but just want to make sure that we're handling them carefully. On the security side, the different hazardous materials could be stolen and weaponized. It doesn't really apply for us in the lithium battery space. This is really more of a focus on, if you're a company that transports cargo tanks of gasoline or poison gases or some of those very high-end hazmats, you want to make sure that everything is properly secured. So for our purposes, it's common sense. You want to make sure that your inventory is accounted for, that you're restricting access to the facility to only those that should be in the building. Doors are locked when people aren't there. All the very, very common sense things that you're already doing. Just keeping in mind that your products are properly secured within the facility. So any questions before we jump into the lithium battery world? Any questions from the team? Okay. Not seeing anything. So let's walk through lithium battery basics. So this is really just how to identify lithium batteries and then some of the hazards that they pose. So if I'm shipping lithium batteries, so step one of shipping any sort of regulated hazardous material is classification. So classification is really just saying, what is it? We need to make sure it's properly classified before we can figure out what type of box we have to use and what type of labels go on the box. So for lithium batteries, the way to perform classification, so if you're given just a random product from your inventory or a random battery from your inventory, these are the steps, these are the four big things that you're going to need to know in order to properly classify it and ship it. So it's battery chemistry, shipping configuration, type, and energy content. So let's go through each of those here. First is battery chemistry. So this is broken down into two buckets. We have lithium ion and lithium metal. So lithium ion cells or batteries are the rechargeable type. So this is likely the battery chemistry that you're using for most of your products. These are, polymer sometimes or pouch cells that are rechargeable. So anytime you have rechargeable technology, we would put it under the lithium ion category. The other category is lithium metal. So these are non-rechargeable, so one-time use. You do see them in certain smaller products, but I think for our purposes, really what we're going to be shipping the vast majority of the time is lithium ion cells and batteries, the rechargeable type. Next thing we need to understand is shipping configuration. So once we know that it's, for our example, lithium ion, the next thing for classification is how is it being shipped, right? So that's kind of what they're asking you. So there are three choices within shipping configuration. We have standalone, packed with equipment, and contained in equipment. So a standalone battery is a battery that is transported without the equipment it powers. So what we have here in our example, and I don't know if you have all of these products in your inventory, but The example of a standalone battery in our world would be the sort of the charging case that you see here on the left side. So this is an individual battery because the equipment that it powers are the hearing aids. So if you're shipping this charging case just by itself, it is considered a standalone lithium ion battery because it's not packed with or contained in the equipment that it powers. Because again, the equipment that it powers are the actual hearing aids themselves. So if they're not shipping with the hearing aids, we need to call it a standalone battery. The next configuration would be charging case plus the hearing aids. So in this case, we have hearing aids being the equipment and charging case being the sort of the battery. And so we have the battery being the charging case packed with the equipment. So this is considered lithium ion batteries packed with equipment because again, the battery is packed alongside the equipment that it powers. The final one would be lithium batteries that are contained in equipment. So this is going to be where the battery is contained inside of the piece of equipment that it powers, like we see here. So this would also be things like laptops, cell phones, where the battery is installed into the equipment it powers. Now the issue here is that the regulators wrote, understandably, the regulators can't write rules for every product under the sun. So when they were developing these regulations, it was a little bit more cut and dry for them. For them, it was, okay, lithium ion battery contained in equipment. Well, that's like a laptop or a cell phone. That's very obvious, right? But for our inventory, we actually have a lot of interesting use cases where it can be difficult to figure out, okay, is this a standalone battery? Is this packed with equipment? Is this contained in equipment? So, we've done, of course, the best we can identifying which products are which, but we actually had a situation here with the charging case, where the charging case, of course, recharges the hearing aids, but it also performs some other auxiliary functions um, for, just on its own. So we actually interacted with the US DOT. We got a letter of interpretation directly from PHMSA to ask them the question is, if we're shipping this charging case by itself, how would we classify it? So is this charging case shipped without the hearing aids? Is this considered a standalone battery or a lithium battery contained in equipment? So the DOT did respond to our letter a couple of years back, and they did clarify that if you're shipping the carrying case by itself, we do need to call it a standalone lithium ion battery. And their reasoning here is, you can see on the bottom, this concept of the primary purpose of the case. The primary purpose of the case is to provide power to the hearing aid. So I think by now we've integrated these definitions into our own systems, but really from our purposes, the carrying cases or the charging cases on their own do need to be considered standalone batteries, which makes our life a little bit more difficult, especially for air shipment. But that's where the DOT stands in terms of classification. So again, charging cases on their own do need to be considered lithium ion batteries standalone, whereas if the hearing aids are shipped with them, they would typically be put into lithium ion batteries packed with equipment. So once we know the chemistry, which for our purposes is mostly rechargeable lithium ion, once we know the shipping configuration, so standalone, packed with equipment, contained in equipment, the next thing we want to know is the type. So what I mean by that is, is it a cell, battery, or button cell? So a cell is just a single electrochemical unit, whereas a battery, from a regulated definition, a battery means two or more cells that are connected together. And then finally, button cell we see here, also called a coin cell. This is where the height is less than the diameter. So for our purposes, we ship both cells and batteries. The actual power source in the hearing aid is a single cell, whereas for some of the charging cases, it is multiple cells connected together to form a battery. And the last thing we need to understand is the energy content. So for lithium ion cells and batteries, the energy content is measured in terms of the watt hour rating. So this would be best thought of as energy content sort of being like the size of the fuel tank. How much energy can that battery hold? For lithium metal cells and batteries, the energy content is measured in terms of grams of lithium. And why this is so important is the regulations change significantly based on the energy content of the cell or battery. So fortunately for our purposes, all cells and batteries that we're dealing with that I know of are considered small. So in order to meet the small definition, we would look at the highlighted portion on the table here. So for lithium ion, if you have a lithium ion battery, if you follow that table, it'll tell you that in order to be considered small or low energy, the battery would have to not exceed 100 watt hours. So it'd have to be equal to or less than 100. Each cell would be less than 20. Each battery or metal cells and batteries. So for metal cell would be less than 1 gram lithium content, for a battery less than 2 grams. So just for our purposes, if we're looking at the hearing aids, the charging cases, they are well under these limits. So they are all considered to be small lithium cells and batteries. And this is important to clarify because, at least as of today, the regulators have things set up to say that the more energy content in the battery, the more hazardous and the more requirements you have to go through in order to ship it. So we're considered small, which means that there are a lot of exceptions that make it easier to ship our products than it would be to ship like an e-bike battery or a scooter battery or something like that. So everything we have is going to be considered small or low energy. And then there's also a requirement to make sure that the types of batteries that we're shipping and using in our products are of a type that have been designed and tested to the UN 38.3 standard. So we don't need to, spend a lot of time on this. This would be done during the product development phase. What this is a series of 8 tests that are meant to simulate that a given battery is safe for the purposes of transport. So the tests are things like uh, overcharge, rapid discharge, altitude simulation, vibration, shock. So things that, again, would show that the battery is safe for use and safe for transport. It's the manufacturer of the cells and batteries that have to conduct these tests. So I don't think Starkey's actually manufacturing cells and batteries. They're likely buying them from a supplier who should have already performed those tests. So the manufacturers actually do need to maintain records, and you also have a system in place where downstream distributors do need to maintain a copy of the test report, or I should say the test summary requirement, and that just came into effect at the beginning of this year. So this is something that want to make sure for each type of cell or battery used in your equipment that you have a UN 38.3 test summary document available, and typically that would be made available from the original manufacturer of the cell or battery. So that's just something more on the paperwork side to be aware of. So based on the chemistry and configuration, we would actually be putting our products into one of the 6 categories for lithium cells and batteries. So if I go into the regulations and look up in the hazmat table entries for lithium batteries, there are really only 6 entries that are going to apply. So UN 3480 is the UN number assigned to lithium ion batteries. So that would be standalone batteries. And then UN 3481 is the identification number assigned to lithium ion batteries packed with or contained in equipment. Same concept for lithium metal, where you have standalone lithium metal batteries being assigned to UN 3090, and then UN 3091 is going to be for lithium metal batteries that are packed with or contained in equipment. So from our perspective, it's my understanding that really it's the first 3 entries that we're going to be dealing with the most. So within the operation, we're definitely going to be shipping standalone lithium ion batteries, which would be UN 3480. We're also going to be shipping a lot of lithium ion batteries packed with equipment, as well as lithium ion batteries contained in equipment. So for what we want to really focus on here, are these top three entries and these two UN numbers, 3480 and 3481, because those numbers are going to be used a lot on the actual labels of the package. And we're going to cover all of that in the next section. But before we do, I think it's worth understanding, uh, why do we have all these regulations in place? So as we'll get to, some of these regulations can be a little bit complex and confusing. So why is it necessary to have all of these packaging and labeling rules in place for shipping lithium batteries? Well, the answer there is under very rare circumstances, lithium batteries can pose some pretty major hazards. So the kind of the term that we'll always think about here is thermal runaway. So a thermal runaway is really best described as an uncontrolled energy release. So if you think of what the purpose of the battery is, so the purpose of a battery is to store energy and then release that energy in a controlled manner to power a device, let's say. The good thing about lithium batteries from a performance perspective is that they hold a lot of energy in a very small amount of space. So that's why lithium batteries are used in everything from small, tiny hearing aids all the way up to electric vehicles, is because they hold a lot of energy. Problem, though, is when things go wrong and all of that energy is released at one time, that's where you see the major hazards of lithium battery thermal events. So different batteries react in different ways, but oftentimes for lithium ion batteries, you'll see the battery will overheat and self-ignite. Some batteries are sealed that they'll actually explode or overpressure. And then a lot of the batteries that when they fail and go into thermal runaway, they're going to vent a pretty good quantity of toxic and flammable gas. And this is really where, the concept of a unique hazard comes in. This is what the FAA on the aircraft side is always worried about, is that although extremely rare, lithium batteries can be both an ignition source and a fuel for an existing fire. So, this is certainly concerning to, for example, pilots, that if you are shipping large quantities of lithium batteries on an aircraft, that again, even though extremely rare, a battery can have an internal malfunction, an internal short circuit, start to overheat and self-ignite. So again, on the battery side, it's estimated that it's something like 1 in 100 million batteries would be likely to undergo that internal short circuit and self-ignition. So it sounds like, hey, 1 in 100 million is a crazy number, and that's true. But the reality is there are billions of lithium batteries being transported every year. So even if the likelihood of, one incident is pretty low, once you have billions and billions of these shipments being made around the world, unfortunately, incidents do happen. So we have an example here. I don't think the video, or sorry, I don't think the audio is going to come through on the webinar, which is fine. What we have now is almost 6 years ago. This was at the NASA Jet Propulsion Lab out in California. The team here, the engineers, were working on some type of robotic device that contained a pretty large format lithium ion battery, I think around like 900 watt hours. So way, way bigger than anything that we would have in inventory. And they put the battery up to charge, leave the room, and then you can see here through this video the major incident that happened. So again, the sound's not going to be able to come through, but that's not a problem. So they put the battery up to charge, and so we have a major thermal event. So we have a huge, couple fireballs coming off the side of the battery as a result of some type of failure of the cells inside. So we see the other thing is not only the major first kind of fire that broke out from the battery, but now the other portion of this that you'll notice is that lithium battery fires are very difficult to extinguish. They burn at very high temperatures. And so we have this example of this person going in without really any protective gear, which is a very bad idea, trying to spray it with a couple of the fire extinguishers on the wall. It looks like the reaction has sort of calmed down, but now you can see in the video The open flames are gone, but now you're seeing a ton of gas coming off of that battery. So what's happening is the heat is moving from cell to cell with the battery and just causing failure of all the cells. So they're releasing the gas. Gas is filling the room steadily here, and then eventually the fire is going to, as you see, reignite. So at some point here, we actually have the professionals coming in. I think they're showing the video here, very quick response time, which is great. But they actually have the better firefighting equipment. And even then, as you notice, they have difficulty putting out the fire. What usually happens in these cases is you want to drag the battery somewhere safe where, and let it burn off all of its energy because it might not be a reaction that you can extinguish there on site. So this is just a kind of a I would get back to almost like a worst case scenario. I don't think any of the batteries that we're dealing with none of them are even close to this size. But still, even with that said, even a small battery, even if you're looking at it, it might seem small, but it can hold a lot of energy. And if things go wrong, that energy can be released and produce certainly overheat, emission of toxic gases, and sometimes self ignition. So we just need to be aware of that. Now, what causes this type of battery failure? There's a lot of causes. The best example, or probably the most common in our environment, would be physical damage. So this is if it's batteries are dropped, dented. We see a lot of, unfortunately, in the distribution environment, we do see cases where you might have a pallet load of products that are hit with a forklift. So the forklift punctures through the packaging and hits the product and the battery itself. So I have seen pallet loads of laptops catch on fire for that exact reason. So it's important, again, going back to making sure we're handling batteries with care. Another cause of battery failure is excessive heat. So if you look at the picture on the right-hand side, this is a cylindrical diagram of a cylindrical cell where you have the anode and the cathode. And we have electrons moving between those two. That's where you get sort of the steady stream of energy release. The problem is if you damage that separator, that's where you can have direct contact between anode and cathode, which causes all of that energy to be released at once, or you get the fires. So it also can be caused by manufacturing defects, poor design, overcharge, contacting conductive materials, and then just general extended life. So if you have a battery that's been charged and recharged a whole bunch over the course of 5 or 10 years, it can build up internal defects that would make it more likely to have that type of short circuit and fire risk. So I think for our purposes, really, we're going to be mainly, I don't think we're too worried about things like poor design or manufacturing defects or overcharge. We probably shouldn't really even be too concerned about exposure to excessive heat. I'm sure that our products are kept in a distribution environment that's relatively temperature controlled. It's never going to be over 150 degrees Fahrenheit, certainly. So for our purposes, I think the one that we want to just keep an eye out for would be that physical damage, making sure that we're not, hitting them with forklifts, dropping them from high heights, things like that. And so we saw that incident at NASA, but the reality is, again, unfortunately, there have been incidents in transport, which is why these regulations exist, is to try and prevent these types of things. So the first one, this is from 4 years ago. This was a shipment of 55-gallon drums, and the drums contained lithium batteries that were being transported to be recycled. And so there was a thermal runaway inside one of the drums. The heat spread to the other batteries in the drum. And what ended up happening in this example, unfortunately, was there was a huge, massive thermal runaway event, and it filled the freight container, the metal freight container, with flammable gas, enough flammable gas that ignited and just exploded, the 55 or 53-foot freight container and broke it open, which, if you can imagine, takes a lot of energy to do that. This was fortunately no one was injured during this event, but there was a lot of damage, not only to the rail car that you see there, but even there were houses nearby where the windows were blown out due to the massive explosion. The other, well, not the other, one of the most infamous examples was UPS Flight 6. This was now in 2010, I believe. A cargo plane operated by UPS was leaving Dubai in the United Arab Emirates. And within 15 or 20 minutes after takeoff, the pilots reported smoke in the cabin. The pilots, at that point, of course, turned around to make an emergency landing. But what ended up happening was the fire and the smoke had gotten so thick that they couldn't see, uh, the control panel in front of their face. So they were tragically, literally flying blind. Went in for an emergency landing. The plane crashed, killed both pilots. And of course, as you'd imagine, this sparked a whole new round of concerns and regulations around transporting lithium batteries because uh, the the um, the investigation into the cause of the accident was pretty clear, that this onboard fire was started by auto ignition of lithium batteries. There were multiple pallet loads of lithium batteries on the aircraft. And so this was a major disaster. There was actually one not long after this in Philadelphia, another UPS plane that caught fire due to auto ignition of lithium batteries. Fortunately, in that example, the plane did make an emergency landing and no one was hurt. But of course, the plane was consumed by the fire. So these things happen on rail shipments, on highway trucks, on ocean vessels, on aircraft. I'm sure there may have been some of you heard recently the fire on an ocean vessel that was, kind of sitting out at sea for a long time and burning up. And that fire seems to be pretty certain to be started by some lithium battery powered vehicles that were on board the vessel. So that's, another unfortunate incident for the battery shipping world, and this is why these rules and regulations exist. We also have, just to be aware, I don't think this is going to be a major concern for our operation, but lithium batteries that are damaged, defective, or recalled are those that pose a higher risk of thermal runaway when in transport. So again, I think for our purposes, we're unlikely to really encounter any damaged defective batteries, especially on the distribution side. There's probably no reason that we would expect them to be damaged. Usually when you see damaged batteries, it might be a return shipment from a customer, or the product was beaten up, or used heavily or used and abused. For our purposes, we just want to make sure that if we see any signs of damaged batteries, that we want to take them out of the normal shipping stream, to be packaged and shipped under the damaged defective rules, to be shipped out for disposal. So DDR batteries would include known manufacturer defects. So this is typically recalled batteries. Those that are swollen, hot to the touch, maybe they have significant dents in the case or punctured cases. So when in doubt, we just want to make sure that if we do see signs of damaged defective batteries, that we are, shipping them, or I should say, taking them out of the normal shipping channels to be handled differently, because they do pose that higher risk in transport. So any questions here on battery basics before we launch into the final section? And the final section is going to be really the function-specific instructions on how to package, label, and document our shipments of lithium batteries by both highway and aircraft. So any questions on battery basics? Okay. Not seeing any hands up in the chat, so let's go through and look at some of the more function-specific requirements here. So this is the stuff that, we talked about general awareness, we talked about some of the hazards and classification of batteries, and that's all good background information to have. But now we get into this section. These are the real black and white rules that we need to meet if we're shipping lithium batteries and lithium battery powered products, which of course we are. So let's start with packaging. For shipping lithium batteries and battery powered products, first step is to use a package that's capable of passing a 1.2 meter drop test, which I'll talk about here in a second. So unless you're shipping batteries contained in equipment, so for our purposes, if we're shipping charging cases or the hearing aids with the charging case, they need to be in some type of outer package that's strong enough to withstand normal conditions of transport and, withstand that 1.2 meter drop test. So this would just be a strong, rigid outer package. So from the inner works of it, we need to make sure that the batteries or the charging cases, for example, are completely enclosed in some type of inner packaging, and then that inner package goes into the strong outer box. So that inner package could be a plastic bag, it could be a smaller, cardboard retail type box. However you want to do it, it's fine as long as, in our example, the charging case is going to be completely enclosed by something. So you don't want to just put a charging case just on its own into an outer box and ship it that way. It does need to be enclosed by something to protect against short circuit. If we're shipping lithium batteries contained in equipment, we want to have some way to prevent accidental activation of the equipment. That could be an on-off button, that can be power down, however you want to do it. We just need to make sure that we're not going to have accidental activation of the equipment during transport. And then, of course, we want to make sure that we are securely putting the batteries in the equipment inside of the outer package. So if there's significant void space, you want to use filler materials, cushioning materials to make sure that if I picked up the package and shook it around, that the batteries are not going to be bumping all over the side walls of the box. I want to make sure they're secured in there. And then again, we just need to use that type of strong, rigid outer packaging. UN performance package would not be required. So just as a battery example, we have a battery going into a plastic bag, which would be the inner package. We put that in a strong, rigid outer packaging, use filler materials to make sure it's secured in there. This one is important for us. We want to make sure that we're not using padded envelopes for these shipments, sometimes called jiffy mailers, soft packs. There's a bunch of different terms for it, but we do need to use some type of strong, rigid outer packaging like a cardboard box would work. The reason that soft packs are not allowed is because we have had incidents in the shipping stream where certain products or batteries can be crushed. And if they are crushed, they're going to be likely to enter that thermal runaway and cause fire. That has happened, not with our products that I'm familiar with, but that has happened with products at, for example, Postal Service sort centers where they go through a machine and the machine crushes the battery and causes a fire. So that's why you always need to have some type of strong, rigid outer package that can withstand normal circumstances of transport, including normal, stacking forces or crushing forces that you might see. We talked about that drop test. The drop test is pretty simple. It's saying that if you're shipping lithium batteries or lithium batteries packed with equipment, the outer box you use has to be capable of withstanding a 1.2 meter drop test, which is about 4 feet, without damaging cells or batteries or having the box break open and the contents fall out. So it does say it's capability standard, so you do not actually need to perform the test on each individual box. You can sort of certify that the box is capable using package specifications, use history, manufacturer certification. There's a whole bunch of ways to do it. Really, the best way to think about it, though, is your outer box that you're using for these shipments, is it of normal construction that it would withstand a 4-foot drop without breaking open, which I'm sure in your case, that's not really an issue. But just do need to keep that in mind because it is a requirement. It's just something to make sure that the package is safe for transport. So once we have the packaging requirements met, which the packaging requirements for small batteries, it's pretty straightforward. It's, have some type of inner package to prevent short circuit, package the battery and or battery powered products securely in the box so they're not rattling around inside, and then using just some type of sturdy outer box. And that could be cardboard, plastic. It can really be a lot of different things. But once you've met the packaging requirements, the next thing we need to do is what we call communicate the hazard. So this would be putting a lithium battery mark on the outside of the box. So there are a couple exceptions, which I'll talk about here in a second. But for the most part, If we're shipping lithium batteries and lithium battery powered products, we should expect to have a lithium battery mark like you see here on the outside of the package. So the rules on this internationally just changed in terms of the size of the marking. So the mark that you see here with the red border and the battery pictogram uh, previously had to be 120 millimeters by 110. They've reduced that minimum size internationally down to 100 by 100. I say internationally because the US DOT hasn't quite yet got around to adopting that requirement. It should be coming soon, probably this summer. It'll be officially on the books. But there's a lot of my clients that have already switched over to the smaller size 100 by 100, and I would not expect that that would cause any issues for transport. So the mark looks kind of like you see here. The first star would be replaced by the UN number, and the second one would be a telephone number for additional information. The telephone number does not need to be a 24/7 number. It can go to a normal business line. And in addition, got some good news on the telephone number requirement. It does look like that's going to be eliminated starting in 2023. So this is something that, a year from now, you probably don't need to have that telephone number marked on the actual lithium battery mark. But as of now, we do need to keep it in there. So when we talk about UN numbers, this is really what we're talking about. So you've probably seen a bunch of these labels at your site, but if we're shipping spare batteries, standalone batteries like a charging case by itself, you would need to use the lithium battery mark with the UN number 3480, because that 3480 corresponds to sort of the identification number for standalone lithium ion batteries. If we're shipping lithium ion batteries packed with or contained in equipment, the label we need there is UN 3481. And then for lithium metal, we have the same concept. I don't think you're moving a lot of lithium metal batteries, but if you are, lithium metal batteries standalone is 3090. Lithium metal batteries packed with or contained in equipment is 3091. So that's what those outer packaging labels look like. Again, you're probably very familiar with them. There's another label or mark that we need to be aware of in addition to what we see here. And this really only applies for standalone lithium batteries, so lithium ion and metal. So as of 4 or 5 years ago, the international community agreed to prohibit transport of standalone batteries on passenger aircraft. So in order to sort of ensure that standalone batteries are not going to be loaded accidentally onto a passenger aircraft, there's an additional requirement that just applies to these standalone shipments for all transport modes. So the package has to have not only the lithium battery mark we saw on the last slide, but it has to have either the cargo aircraft only label that you see here, or this sort of text version where it just says lithium ion batteries forbidden for transport aboard passenger aircraft. It seems a little strange, if you're making a highway shipment of a standalone battery to put a cargo aircraft only label on the box, because it seems like that's, telling somebody to put it on a cargo aircraft. But really what this is intended for is just this extra label on the box to prevent the standalone battery from accidentally being loaded onto a passenger aircraft. So even though if it's going by highway, you wouldn't think that it would need these types of labels, it does. So for all transport modes for standalone batteries, you do need to have either the cargo aircraft only label you see on the left, or the text version that you might see on the right-hand side. And that's something, unfortunately, is often missed by a lot of shippers. So just keep in mind that is a requirement, for example, for, even for ground shipments of the spare chargers. Now, there are two exceptions where the lithium battery mark on the outside of the package is not required. The first one is if you have button cells installed in equipment. So button cells we talked about earlier is just like a coin cell, looks like a coin. Those are typically very low energy, pose very little hazard. So the regulators say if you have button cells contained in equipment, they're such a low hazard that we don't really even need to consider it. So there's no requirement to have any sort of lithium battery label on the outside of the package. So we talked about undeclared packages earlier. If you're fitting the exception, these two exceptions that we're talking about, it's not considered an undeclared package because the regulators are saying you don't have to put the label on the outside of the box in these two circumstances. So number one, button cells installed in equipment. The second exception is even trickier. So this exception says that if you have no more than 4 cells or 2 batteries contained in equipment in a package, and there are not more than 2 such packages in a consignment, then you can ignore or not put the lithium battery mark on the package. So a consignment here is the regulatory term, and it means a load of packages going from one origin to one destination address at one time. So let's use an example here because this is a very confusing exception. Let's say I have 2 laptops in this box. So if I look at the second exception, I have not more than 2 batteries contained in equipment. Yes. If I ship 2 of those packages from my location to your destination address, that would be considered one consignment. And so in this example, you have not more than 2 batteries per box. So you checked that. And then the other thing is you have not more than 2 packages in that consignment. So you check that. So that means you can use the exception and you don't need to have the lithium battery mark. Let's use that same example, but now I ship 3 of these boxes from my location to your location at one time. Well, at that point, each package contains not more than 2 batteries. That is true, but you're now shipping more than 2 in that consignment. Therefore, each package needs to have, in this example, that UN 3481 mark displayed. This can be a very confusing exception to manage, because then you have to think about, how many products were in the box, how many boxes are going to one destination versus 10 destinations. So 99% of my clients really just make it a rule to say, listen, if there's lithium batteries being shipped, either contained in equipment or not, we always just have blanket policy to say we're always going to put the lithium battery mark on the package as applicable. So even if we have a small one cell phone in a box, technically we might not have to put the lithium battery mark on there, but rather than try to manage, the complexity of that, we're always just going to make it standard policy to put the lithium battery mark on the box anytime that we're shipping any type of lithium battery, including lithium batteries contained in equipment. So that's kind of my expectation of what your team would be doing as well, is always putting that lithium battery mark on the outside of the package for battery shipments. And that's typically best practice and a very easy universal solution. And if we're still talking on the marking and labeling side, I do want to mention here, if you are shipping overpacks. So an overpack is a collection of completed packages that are typically shrink wrapped or put into another type of container to make it easier to handle them and transport. So the best example of an overpack would be, 15 completed packages put on a pallet, all shrink wrapped together. That would be the definition of an overpack. But when you're shipping overpacks or pallets, keep in mind that there are no weight limits in terms of the weight of the pallet. All the weight limits and the quantity limits apply to the weight of the packages on the pallet. And if you're shipping pallet loads, you want to make sure that the labels on the packages inside are either visible through the shrink wrap, or if they're not visible through the shrink wrap, would be reproduced on the outside of the pallet along with the word overpack. So here's what I mean by that. Let's say you have, in this case, looks like some spare lithium metal cells. So I have 4 packages, put those on a pallet, I shrink wrap it. But in this example, I'm shrink wrapping it with non-transparent or black shrink wrap, so I cannot see the labels on the packages inside. So if that's the case, I need to repeat those labels on the outside of the overpack along with that word overpack. So that gets us to sort of the general requirements on packaging and labeling. Now let's go through some of the quick differences that may apply whether you're shipping something by highway and ocean versus shipping something by air. What I want to emphasize at least for the types of small battery shipments we're making, shipping by ground and ocean is relatively easy, or I would say lightly regulated. So here's what I mean by that. So if I'm shipping something by highway, rail, or ocean, I need to have it packaged securely in a strong outer box. So we talked about that already. I need to have the lithium battery mark displayed on the outside of that box, and I need to have either the cargo aircraft only label or the text version for standalone batteries. So that's really it. It's, package it securely, strong outer box, have the lithium battery mark displayed. If I'm meeting those standards, there's no requirements for me to complete any type of regulated shipping paperwork. There's no hazard class 9 label. There's no requirements for placarding or UN performance packaging or hazmat endorsement for drivers. It's really just package securely, put the lithium battery mark on the outside, and you're good to go. And this is what I mean by that. You have in these examples your standalone batteries, UN 3480, and you have that extra text marking, lithium ion batteries forbidden for transport aboard passenger aircraft. But then for lithium ion batteries packed with or contained in equipment, you'll notice that it's really just, again, a matter of putting that lithium battery mark on the package so it's prominently visibly displayed. There's no weight limit that you need to worry about when you have packages that are containing lithium batteries packed with equipment or contained in equipment. You do have a total package weight limit for shipping standalone batteries, but that weight limit is 66 pounds gross weight. So in our example, I don't know all the ins and outs of the operation, but I kind of doubt you have packages with standalone batteries that would weigh more than 66 pounds on their own. Likely they're probably smaller, keeping under 20, 30, 40 pounds. But just keep in mind that would be the only package weight limit we would need to be concerned with for ground and ocean transport. Otherwise, it's pretty flexible in terms of the amount of product allowed in these lithium battery packages. So this would be the example for lithium ion. This was the example for lithium metal. So it's the same thing. It's just, of course, the UN numbers on the packages have changed to represent that it's not lithium ion in here, it's lithium metal. But the weight limits all stay the same, as well as having that extra marking for standalone cells and batteries. So again, ground transport, it's relatively straightforward. So just using some of our examples, again, for ground transport, we have the charger. We talked about the charger being a standalone battery. So the package would have that mark, UN 3480, and then it has the other mark that says lithium ion batteries forbidden for transport aboard passenger aircraft. So again, this is just examples of, hopefully how straightforward these ground and ocean shipments will be. You have the chargers that are in some type of inner packaging, like a smaller retail box. They're packed securely in the outer box. You're not exceeding 66 pounds. And then you have those two marks that you see on the package, 3480 and the lithium ion batteries forbidden mark. So that's how it would look just as a real world example for chargers. For some of the devices though, also very simple. For the devices, you have them packaged in a way to prevent movement. So they're secured inside of there. And then you just have that 3481 mark applied to the outside of the package. That's it. No paperwork, no class 9 label, no placarding to worry about. Just pop the label on the box and send it out the door. Emphasis on ground. So again, ground transport, very, very simple in terms of securely packaged, put the label on. Air transport is more complicated, especially air transport of standalone batteries. So let's look at the air transport requirements here. The first thing you'll notice is air transport is more, I guess to put it this way, you want to make sure all of your shipments are meeting the rules. But when you're shipping by air, you want to double or triple check that you're meeting all of the rules, because air transport, air shipments are definitely subject to more oversight from enforcement agents. We talked earlier about some of the incidents that have happened on aircraft. The reality is incidents happening anywhere is bad, but a fire on an aircraft is an absolute catastrophe. It's very, very hard to extinguish a fire on an aircraft, and it puts people's lives in jeopardy in a way that typically, if there's maybe a fire on a truck, you're going to have a lot of property damage, but it's not necessarily always going to result in some type of loss of life or major injuries. We also have a lot larger financial penalties for violations made for air transport of batteries. We have more rigorous carrier acceptance checks. So what I mean by this is, you can offer 10 packages for highway transport and, in reality, the driver, the carrier is probably not going to be doing a thorough review to make sure that all of the packages are meeting the required marks and labels. Air transport's different though. So when you tender things over to UPS or FedEx and they take these packages, they look at the package and typically they do a pretty thorough review of each package. And if there are mistakes made, you are likely that the package is going to be sidelined and possibly found out by a DOT enforcement. So again, you also have additional hazmat carrier fees, carrier variations. So this is all just to say for shipping by air, especially shipping spare batteries by air, there's a lot more hoops to jump through. So we do need to be sure that we are careful and meeting the standards that we need to meet. So we talked about the UN numbers and the six descriptions for lithium batteries. Same concept for air transport under the IATA dangerous goods regulations. The only difference here is, let's focus on the top three. These are the ones that we're shipping. The regulations for the air transport for IATA are set up a little bit different in the sense that each of these descriptions is assigned its own packing instruction. So that packing instruction is pretty simply just the point in the regulations where it tells you what type of package you have to use, what type of label, and what type of limits might apply. And even within those packing instructions, there are different sections. So for standalone batteries, at least as of today, we have three sections, section 1A, 1B, and section 2. So we can pretty much cross off section 2, that no longer applies. So for standalone batteries, section 1A is going to be for large batteries, so things over 100 watt hours like a scooter battery or e-bike battery. Section 1B would be for smaller batteries like the ones that we have. So section 1B requirements, as we'll talk through, would apply for air shipments of standalone lithium batteries. So the examples being the charging cases that we have. For lithium batteries packed with or contained in equipment, it's a little bit more straightforward. You have section 1, this is going to be for large batteries, and then section 2 is how we would make our small battery shipments by air. And as we'll see, shipping small batteries that are either packed with or contained in equipment is a lot easier than shipping small batteries standalone. So let's start on the standalone example. Let's say we need to ship one or more of the chargers by themselves. They're going to be considered standalone batteries. And if we want to ship them by air, we have to follow the rules that I'm going to lay out here. So number one, the package limitation. So we cannot have more than 10 kilograms net weight of batteries in the box. So that's actually would be a lot of batteries. I don't know how much the individual charger weighs, but 10 kilograms is 22 pounds. So we do have a lot of room in terms of how much quantity we could put into a package, but the package is going to be subject to a lot more requirements than it would be, for example, for ground transport. We would need to have, again, this is only for air transport of standalone batteries. We need to have the Class 9 label and the cargo aircraft only label. So that's what that Class 9 label looks like. We would need to mark on the package the UN number and proper shipping name, along with the net quantity of batteries in the box. We need to have that UN 3480 lithium battery mark. We need to complete a regulated shipping paper called the Shipper's Declaration for Dangerous Goods. We would need to have a mechanism to ensure that the charger is at a state of charge not exceeding 30% of its rated capacity. And then we would still be subject to packaging it in a strong, rigid outer box. UN performance packaging is not needed. So there's a whole host of things that we would need to comply with. So let's start with state of charge. If we think of the energy content is the size of the fuel tank, the state of charge is how much fuel is left in the battery or left in the tank. So for air transport of standalone lithium ion cells and batteries, we need to make sure that the state of charge does not exceed 30%. Reason here is safety. So this regulation was put on the books now about 6 years ago, and this is all based on battery failure testing. So it's pretty straightforward to say that when you have a battery that's fully charged, when it goes into thermal runaway, it produces a reaction that's more violent than one that's at 30% state of charge. So this is how the safety factor was developed. As you can kind of see, one of the examples from, I think this is from the FAA, showed the heat release rate is significantly lower. If you look at the red peak is 100 SOC, the purple peak just off to the right would be at 30%, and you can see the much less reactive battery when it's at 30% state of charge. So that was the methodology or the philosophy behind this. But the reality is it's really difficult for enforcement to measure this, and it's also in some cases difficult for shippers to comply. So for our perspective, it could be something that I think some of your cases have sort of just a light display that it might mean, if there's two lights, that's 40%. If it's one light, it's 20%. So in order to ship it, you would want to make sure it's, one light is displayed in terms of battery capacity. Other way to do this is, if you're working with new product, you want to make sure that the manufacturer is shipping it to you at less than 30% SOC. And as long as they can verify that they're shipping it to you at less than 30%, if you're not charging it on site, you can then just turn around and ship it just how as it came to you, because it's not going to obviously increase state of charge over time. So there are various ways to handle this, but just keep in mind that this would be required for standalone cells and batteries, including some of those chargers if they are shipped by air. So in addition to state of charge requirements, we also need to complete that regulated shipping paper. So the I'll show you an example here, but it does need to have the following information. So you'd have that basic description, so UN number, proper shipping name, hazard class. You would have to indicate the number and type of packages. We need to indicate the weight of hazmat, in this case, weight of batteries being shipped. We need to include an emergency response phone number along with emergency response information. And then finally, sign onto a shipper's certification. So I'll go through that example in a second, but we do want to make sure to note that if we are making standalone battery shipments by air, that the shipper's declaration form is required, and we have to maintain a copy of each form for at least 2 years. So every time we make one of these shipments, we're going to produce that shipping paperwork and then keep either a hard copy or electronic copy of that form on file for at least 2 years. That's definitely another thing inspectors like to ask about. For transport, there's a specific way that form has to look and specific information you need to include. So this is the top half of the form. The form is called the shipper's declaration for dangerous goods. The top half would need to be filled out kind of like you see here. So shipper and consignee, that should be pretty obvious where it's from, where it's going. Air waybill number, usually the carrier is going to complete on your behalf. Page 1 of 1, 1 of 2, however many pages you're offering. Usually in our case, it would be page 1 of 1. On the bottom left, there are 2 boxes here. We need to cross off the one that says passenger and cargo aircraft. So what we're doing here is crossing that one off, so the only one that's visible is cargo aircraft only, and you have to do that because standalone batteries can only be transported on cargo aircraft. We'd also indicate the city or airport of departure and destination, and then finally, on the bottom right-hand side, you see 2 boxes, radioactive, non-radioactive. We would cross off the one that says radioactive, of course, because what we're shipping is not radioactive. So that's the top half of the form. Should probably always look something like this, should be relatively straightforward. The bottom half of the form is where we're going to enter that dangerous goods specific information. So we talked about the basic description, which would read just as you see here, UN 3480, lithium ion batteries class 9. Lithium batteries are not assigned to packing groups, so we would leave that blank. Quantity and type of package. So in this example, we have 1 fiberboard box times the net weight of the batteries being 7 kilograms. packing instruction 965, which is just the one that aligns with standalone batteries. And then we talked about section 1B. So this is where you would just include a quick note there that says 1B. Additional handling information. This is where you're going to put that emergency response phone number. And then finally, you have the shipper's declaration on the bottom half here that just says, I hereby declare everything is in proper compliance with the regulations, basically, is what it's saying. And the person that signs off on that shipping paper, number one, well, obviously needs to have training. That's a no doubter. But number two, the person signing off on that shipping paper needs to have a pretty high level understanding of the hazmat regulations, because ultimately, if you see the statement on the left, it is saying that this specific person is declaring that the lithium batteries are packaged and labeled in accordance with the regulation. So usually this person taking on a little bit higher level of responsibility, and if there is some type of incident or violation, oftentimes that person is going to be the first person asked about it because they were the ones that certified it was in compliance. So just keep that in mind. It's, you want to make sure that the person signing off on these documents, again, not only trained, but definitely knowledgeable about the process. Anytime we have that shipper's declaration form, we do need to provide emergency response information. So there are two things. Number one, written form. So this could just be a safety data sheet or a page out of the emergency response guidebook. The other thing we need to provide is an emergency response telephone number. So this would be monitored at all times the package is in transport. So basically a 24/7 phone number. And this is typically, farmed out to a third party like Chemtrack or Chemtel. That's kind of what the Section 1B shipment might look like. You have all of those labels. So we have UN 3480 lithium battery mark, cargo aircraft only, net quantity, class 9 label, UN number, proper shipping name on a tab off of that class 9 label. And then we have that regulated shipping paperwork with it as well. So, if you are shipping these standalone batteries by aircraft, it is doable, but I just want to reiterate here that you just have to jump through a lot more hoops in terms of state of charge, extra labeling, extra documentation, likely extra carrier fees or hazmat fees from UPS, FedEx, DHL, whoever you're working with. Those standalone battery shipments by air are just a lot more complex. Definitely, shipping batteries that are contained in equipment or packed with equipment by air is much easier. So these are going to be shipped in a very, very similar manner to how they're shipped by ground. The only difference is the amount of quantity authorized per package. So if you're shipping lithium batteries contained in or packed with equipment by air, we need to have the lithium battery mark. We need to have that strong outer package. So it's basically the same thing as ground transport. So here's what it would look like. So standalone batteries we see on the left there, we already talked about section 1B, all the requirements that go into that. But for section 2, packed with contained in equipment, it looks the same as ground transport. Again, the only change here is what you see at the bottom. It says net weight limit 5 kilograms. So if you remember, for ground transport, there is really no weight limit. For air transport, the weight limit is a net weight of batteries of not more than 5 kilograms. So when they're talking about net weight, it's just the weight of the batteries, not the weight of the equipment or the weight of the package. Here's what it would look like for lithium metal. Same thing, just of course, the UN numbers have changed. So this does come up a fair amount, misconception in terms of what that net weight actually means. So if I have batteries that are packed with or contained in equipment, you can have no more than 5 kilograms net weight of batteries inside of each package. And again, this is only the weight of the cells and batteries. It does not count the weight of the equipment. So the easiest way to think about it would be, if I took the battery out of, the charging case, let's say, how much would that weigh? So a lot of the batteries that we're working with are very, very, very light. So what that actually means is you might have, it might take 100 hearing aid cases and hearing aids to actually reach a limit of 5 kilograms. So you're probably not shipping that type of quantity per package. So I think, just as one of the examples, this is just an example of it. I didn't see on the specification to see how much the battery weighed. But let's say the battery weighs 10 grams, you can have up to 500 devices in the box and still be under that 5 kilogram limit, because again, all we care about is the net weight of the batteries inside of the box. The package itself, if you have 500 hearing aids in the package, it's going to weigh more than 5 kilograms, of course, but the weight of the batteries is the only thing to be focusing on. And then the last thing here, before we wrap it up, is if you are offering an airway bill, which most of the time you're not, but I thought I'd leave this in here. Usually what happens is if you offer your products, if your packages to a UPS, FedEx, DHL, they would pick up those products, truck them over to, whatever the nearest airport is, consolidate the packages, and then typically UPS and FedEx produce the airway bill. But there are some of my clients that do have to produce their own airway bills. And if you fall under that category, which you might not, there's just a requirement that you have a sentence on the airway bill that reads like you see here, just says lithium ion batteries in compliance with section 2 of packing instruction 967. So the only thing that would change would be ion or metal. And then the only thing that would change on the back end would be the appropriate packing instruction. 99% of the time, you don't need to worry about this because, again, this is something the carrier is going to be completing on your behalf. So it looks like we're wrapping up here. Definitely have some extra time for questions, which is great, but just a handful of quick reminders before we call it a day. Number one, just to reiterate, some of the products that we have they don't fit neatly under the shipping configuration categories. Um, they don't always fit perfectly under them. It's not obvious. It's not always a cell phone or a laptop or a power drill. We have some products that are more complicated in terms of, functionality. What is the primary purpose of the charging case versus the hearing aids? So we want to make sure that as we're adding new products in, making sure we get that shipping configuration accurate. So the charging case, for example, being shipped on its own is going to be considered a standalone battery. Just as a reminder, when we can, shipping by ground and ocean is usually, certainly shipping by ground is usually cost effective, but there are far fewer restrictions for shipping for air transport. So when we can get away with it, shipping by ground is usually good from a regulatory point of view. But of course, that's not always possible. So if we are shipping things by air, it's still doable, but we really need to make sure if we're shipping the standalone batteries by air, that we are very careful with how we make those shipments, because those are the ones, again, that require that state of charge, that regulated shipping paper, the Class 9 label. Those are the ones that are going to get the most scrutiny from both our carriers as well as from enforcement teams. And then finally, just always like to reiterate, keep in mind that you could at some point encounter damaged batteries, and damaged batteries are a major concern for any lithium battery shipper because those are the ones that are more likely to cause a fire during transport, which of course is something that we want to avoid. So if you do see some of those signs of damage, or if the batteries have been hit by a forklift or run over or something like that, want to make sure that those are not being shipped under the normal processes. So let me pause here. Well, actually, let me first say thanks again for taking the time this morning to talk about lithium batteries. I know I threw a lot of information at you, but hopefully that was helpful to get kind of that better understanding of the shipping requirements. After the training, again, I do recommend going right over to complete the quiz. And once that quiz is complete, I can issue the training records. So I do want to thank the team here, and I'll leave it open here to see if anybody has any questions on the material that we covered this morning.
Mike, this is Cheryl. I was wondering, once everyone is finished, if you and I can chat just for a few minutes.
Of course, yeah. So
All
if
right.
we don't have any questions, what I'm going to do is I'm going to stop the recording here, and then I can stay on and discuss with you. That works perfect.
All right. Thank you.